go with the last part of the review. So identify the type function and sketch the parent graph. Well, obviously this is an absolute value. Okay? And then looking at this negative 4 moves it down 4. This negative 2 inside is opposite what you would think and makes it go right 2. So what I would suggest, as always, is use your calculator. If my calculator would turn on. There we go. So clear out what you have. Put in your absolute value of x. Remember, it's math key. Go over one number, enter. Now, the ones in the room, you got the absolute value bars. So you're going to put in just the absolute value of x. On this one, I have to use parentheses. Then go down, and then put in math again over absolute value and x minus 2. And make sure you're using the blue minus key for this. And then graph. There's your parent function. And there's your other one. And move to the right 2 spaces. Now, look at that. The domain is still left and right forever. And the range is still the same. Okay? It's going down as low as 0 and up to infinity. So your domain is negative infinity to positive infinity. And your range is 0 inclusive, bracket, up to positive infinity. Now this one, again, we have an absolute value function. And now this is going to move it up 1. And this plus 4 is the opposite. It's going to move it left 4. We could go back into our calculator and do the same thing. So now we just go down to 3. If you want to see the new one, and do math over absolute value x plus 4 parentheses, and yours, and the yellow ones, you're going to right arrow to move outside the brackets, and then put plus 1. This is going to change the range. So there's the new one. Notice it is higher because it's at 1, bottoming out at 1. So my left and right is still negative infinity to positive infinity, but now my range is actually 1 inclusive, up to positive infinity, because it came down and is 1 higher than it was. So that's the bottom out of the range. Of course, I forgot to graph these. So here's your parent function. And remember, make sure you graph your parent function on the quiz along with your other one. And then my other one is, oops, I'm wrong there. I forgot to put in this negative 4, didn't I? I did. Let's go back to my calculator. Sorry about that. Go back to my y equals. And go out here and put the minus 4. So sorry about that. So there's my parent. There's my first one, number 25, and there's 26. So notice here, my range is going to change from, instead of being 0, okay, 0 for the parent function, but for the this one, it's not going to be 0. It's going to be negative 4. And here's a little hint. This number here tells you where the range is going to hit. This number here tells you where the range is going to hit. That number goes right here. We'll talk about that also for decay and growth. Very important. So we have our original one there. And then we're going to move, and the easy way to do this is you can use the points from the table, or just take your vertex and move down 4 and right 2. 1, 2, 3, 4, 1, 2. And there's your main one. And remember, it goes up diagonally through the corners of like so. Okay? Or if you wanted to, you could always look at your second table and 0, 0 for the parent, 0, 2, -2 for number 25, and for number 26, it's over here at Y3, 0, 5. So you can use that also. So back to this one, my parent function starts off right here, goes up perfectly through there, and then I'm going to move up 1 and left 4. So starting here, we're going to move up 1, 1, 2, 3, 4, and there's my new vertex. And I can get points off the graph or just go diagonally through each corner and climb on up like so. There's my parent and my transformation. Number 27. It is a quadratic. I know that from the little 2 right here. Okay? So I can graph my original. The y equals. Clear out everything. Go back up. And so I put x squared. And then I'm going to go down to 2 and do in parentheses, left parentheses, x plus 1 parentheses squared. And then put minus 3. And then hit graph. So I can take my original one. Now I can say right here, I know it's going to be down 3. And this is going to move it left 1. And it just was confirmed by my graph. But I'm going to go and put those on. Let's say I look at the points. We know 0, 0, 1 and -1, 1, -2 and positive 2, 4. And these are right off the table, or you kind of might know them already. That's your classic parabola, your parent parabola right there. We can take all those points and just move them down 3, left 1. 1, 2, 3, left 1. There's my vertex. And then 1, 2, 3, left 1. And it's going to be 1, 2, 3, left 1. Right there. And then I can move this one down. 1, 2, 3, left 1. 1, 2, 3, left 1. And it's actually going to go through the other one. Like so. Now, my domain still is going to be left and right forever. My range on the new one, where's it going to bottom out? -3, right there. And it's inclusive. And it goes up towards positive infinity. Quad again. Okay? It's going to move up 2. And it's going to move right 1. And you can go ahead and graph it. I'm not going to put it on here because it's like the other one, but you can go ahead and graph it and you'll see it's the same thing. So with the parabola, it's going to go left and right forever. Without even looking at the graph, I know that's the bottom part of my range. Because it went up 2. So the vertex has moved up 2 spaces. It's also moved to the right, but that doesn't affect the range. So again, I can put my original points on. 0, my 1s, at 2, and at 3. When I say 1 and 2 and 3, I mean positive and negative. And there's my parent one. Now I'm going to move all those points up 2 and right 1. So there's my new vertex right there. I'm going to use blue color for this. There's my new vertex. And up 2, right 1, and up 2, right 1. And from this point, up 2, right 1. And from this point, up 2, right 1. And I can do it with these two. The other ones will be off the chart. And there you go. There is your parent parabola and your transform parabola. Okay, so I'm going to turn page. the x. Okay? So go to my calculator, clear out, go back up. I put in 3 caret x. I'm going to go down here and do 3 caret. Now in this one I have to put in parentheses x minus 1. But on the yellow calculators in the room, and I'm not sure those of you who have personal ones how it works, you get to see. On those calculators, it actually raises it up. So when I want to do this minus 2, I just have to type minus 2 because it knows it's on the bottom or outside of that. But on yours, yellow's in the back, you actually have to right arrow to make it drop down and then put in the minus 2. But I can look at this and predict. Like I said, this is exponential growth. And we know it's growth because this number is bigger than 1, the base number. I'm going to predict that this is going to move it down 2, and this is like being in parentheses, so negative 1 is actually going to move it right 1. And this is going to help me out with my range. So let's see what it looks like when I graph it. So there's my parent one. It's never going to hit 0. And here comes my new one, which never hits negative 2. So I will use some points to graph this so I can remember where it's going to hit. The key thing is 0, 1 is a really good point for 0, 1, 1, 3, and 2, 9. 0, 1, 1, 3, and 2, 9. It tells you how fast this thing is climbing. So then you just kind of come down like this and hit these points and then make a curve and never hit 0. And then just get the same thing for the next one using y2. And it's going to be 1, negative 1, 2, 1, 3, 7. So 1, negative 1, 2, 1, and 3, 7. So I'm going to put those on there. 1, negative 1, 2, 1, and 3, 7. And then when I do that, it's never going to hit negative 2. Just like that. So the key thing to recognize here is just remember that this number here, right here, is very important. It tells you where it's going to bottom out. That's bad 2. I'm just going to start over. Negative 2. But the key thing, remember, for growth and decay, or just exponentials, is you use the parentheses, because it's never actually going to hit negative 2. And it goes on forever up. And the domain, it goes forever left and forever right. That doesn't change. So here we have another one. This is another exponential growth. Okay, and it's going to be 2 to the x, and 2 to the x plus 3 plus 1. So this is going to move it up 1, and this is going to move it left 3, because this is like in parentheses, and it's the opposite of what you think. The domain is going to be the same, negative, positive, negative. It's going to keep opening up left and right. And I can tell you right now what the range is going to be. It's going to be 1, parentheses, positive infinity. Well, let's prove that. So we're going to put it in our calculator now. Y, we'll turn it back on. Y equals clear, clear. Okay, and we're going to put in, I should have put the first one. I know what I did because it's 2. So 2 caret x. Our base is a little bit different this time. And then down here, 2 caret, on mine I have to do parentheses, x plus 3, parentheses. And then for me, I can just put plus 1. You have to arrow to the right to do that. Now on a graph, you can see what's going to happen. There's my classic one, never hitting 0. This one's going to be higher, never hitting 1, and climbing. So let's get some points here. We know from before, over here, the class 1 is 0, 1, 1, 3, and 2, 9. So I can put that again. 0, 1, 1, 3, and 29. And then you just come down. Oh wait, sorry, I can't do that. That's for 3 to the x. Silly me. So let's look at the actual ones here. So this one is still 0, 1. But this time it's going to be 1, 2, and 3, 8. And 4 is already off the chart at 16. So that's enough. That's all I need. So I have 0, 1. I have 1, 2. And I have 3, 8. And it's never going to hit right there. Now, with the next one, if you go back and look at the table, notice 0, 9. 1, 17, already off the chart. So I'm going to move up a little bit and get negative 1, 5, and negative 2, 3. Okay? That's going to give me some other points to graph on. Let's go up and see what else we have. You know, negative 3, 2. And that's, you know, in between. Now it's getting smaller. So I'm going to put those other points on now. So 117 is off the chart. So I'm going to do 0, 9. That's my upper one. And then negative 1, positive 5. And negative 2, positive 3. So we had our calculator. And negative 3, positive 2. Okay? And remember, it's never going to hit 1. So I'm going to bottom out right there at 1. So that's why I knew my range ahead of time. Because it comes from right here. Okay, so piecewise. These are great. So we have actually 3 here. Looks like maybe 4, but we have a fraction. So this first one is y equals 5. Now remember, you have 2 choices here. You can just graph y equals 5, which is a horizontal, and then cut it. X less than negative 3, which means that negative 3, the point negative 3, comma 5, I'm going to put an open dot and erase. That's one choice. That's one way to do it. Or, remember the other way is, come here, go to y equals, clear out what we have, and then put in y is 5. Okay? And then you go to the table. We know what it's going to look like. And we want numbers less than negative 3. So I'm going to scroll up till negative 3 is at the bottom. Not notice they're all the same, but it still gives the idea of going to negative 3 and putting up to 5, putting an open dot, and then going left. Then I'm going to do x squared minus 4. So I get my calculator up. Y equals clear. X squared minus 4. Whoops. You get the minus 4. And I graph. That's the same parabola, just dropped straight down. But notice, I only want between negative 3 and 3. So I'm going to go to my table. And I'm going to find, I put negative 3 at the top here until I get, or at least 3 at the bottom. And there are my points. Okay? There are the points I'm going to use, I'll put on here. So it's going to be negative 3, 5, negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, 0, and 3, 5. I'm going to put all those on here, right here. So 0, negative 4, right here. 1, negative 1, negative 3, and 1, negative 3. And I'm just dropping this whole bad boy down. 2, 0, and negative 2, 0. And now here's the thing I got to pay attention to. Am I going to put open dots or solid dots? Well, on the positive 3, 3, 5, it's going to be an open dot. And the negative 3, 5, it's going to be a solid dot. Now remember in class I talked about this. In this case, you might want to put a solid, solid dot for the 1 number. And then, if you're supposed to have an open dot here, just put an open dot around your other solid dot to signify what's happening. Okay? And remember, like I said, you might want to go through your test, and whenever you have these, put solid dots, and whenever you have these, put open dots, just to remind yourself as you're going through. It's up to you. And now the last one is negative 2/3 x. So calculator up, y equals, clear. And remember, we just put this in. Use the great negative key, 2 divided by 3, because every fraction is a division problem. X minus 2. You can see what it's going to look like. Just a slanted line going through negative 2. But let's look at the table. Now remember, we want numbers greater than or equal to 3. So I'm going to move this down until 3 is at the top. I don't want anything less than 3. I don't want 2. I don't want 1. And there we go. 3, negative 4, 6, negative 6. So I'm going to put 3, negative 4 is where I'm going to start with a solid dot. I'm going to put 6, negative 6, and 9, negative 8. I'm just going to use those 3 points. I'm not going to use all those decimals. Okay? And so here I go. 3, negative 4. 1, 2, 3, negative 4. Solid dot. So this dot is okay because this one up here is an open dot. And I'm going to put 6, negative 6, and 9, negative 8. Oops, this dot should be up here. Like so. I'm going to erase that one carefully. And there are my 3 piecewise functions. Now we'll evaluate. Now remember, there's a couple different ways to evaluate this. Negative 2. We can look at negative 2 and kind of look at it like this and say, which is it going to hit? Well, it's not going to hit the horizontal line, because that starts at negative 3. It's not going to hit this line here because we cut it off at positive 3. So it's going to hit the parabola, which means we need to plug this negative 2 in right there. But since it's kind of nasty, why not use our calculator? We know this is our parabola. So let's look at negative 2. Let the calculator do the work. So right there, it's hitting right there at negative 0.6 repeating. Let it do the work. H of 5. So where's 5 going to hit? 5 is going to hit right here. So obviously, what's it hitting? It's hitting sorry. That's the wrong one. I had the wrong parabola. I had the line here, not the parabola. Sorry, that's the parabola. So I got to clear the line. I got to clear that out and do x squared minus 4. X squared minus 4. And then go to the graph table and say negative 2 is 0. So I got to move this bad boy up. It's actually hitting right there at 0. So we change that to 0. But we know if this line would have continued through, it would have been negative 0.6. Okay, so where's 5 going to hit on this one? Again, it is kind of nasty because that's when we go back here and put it back in. So negative 2 divided by 3x minus 2. Go to the table and look at 5. Negative 5.33. So negative 5.3 repeating. Let the calculator do the work. Does that make sense? Yeah, it does. Right here is about negative 5 1/3. So it makes perfect sense. Another way of evaluating which one is on is just look at the numbers. Okay? Negative 2. Well, negative 2 is not greater than or equal to 3. So I'm not going to be using that line. Negative 2 is not in between negative 3 and 3, so I won't be using that parabola. Oh, I mean, it is between there. Man, I'm losing it. It is between those two, so I'm using the parabola. Here, it's not less than negative 3, so I'm not using the line. With 5, I'm already done. I know 5 is greater than or equal to 3, so I'm going to use that line. So you can either visually use the graph or logically think about the numbers. Either way, whatever works for you. So number 32, we're going to graph x minus square root of x minus 1. Remember what a square root looks like? We're just going to change it a little bit. So we're just going to do second square root of x. And let's just see what the parent function looks like. Then come down here and do second square root x minus 1. Now on the other calculators, it just continues the line until you right arrow out of it. So let's see what this looks like. There's my parent function. And it's really hard to tell there, isn't it? Because it looks like it's overlapping. And it is for the most part. All that happened, think about it, is it moved it right one space. And you can look at the table and see what happened. Okay? So it's just slightly changing it. So we're going to put these points up. We're going to do 1, 0, and then 2, 1, and then 5, 2. And that's enough. So when I go to graph that, I'm going to put 1, 0, 2, 1, and 5, 2. And then kind of get it like that. Now think about it. Our original one was 0, 1. I mean 0, 0. And 1, 1. And 4, 2 instead of 5, 2. And that's why they kind of look like they're overlapping. But notice it just shifted every point one space to the right. So that confirms our belief. Now, domain. How far left is it going to go? 1. Inclusive. That's a horrible bracket. 1 inclusive. Out to positive infinity. Range. How low is it going to go? 0. Inclusive. How high is it going to go? Positive infinity. And that is the end of your review.